So in this video we're going to look at calculating the protons, electrons and neutrons of elements from the periodic table using the numbers that are on that periodic table. We're then going to be able to draw the atoms, and by the end we should then also be able to make those atoms into ions. You will need a periodic table in this video, and you will be able to pause it at times to complete work, so you'll need a piece of paper to write your answers on. Once you're ready, start the video and we can go through what we're going to do to start. So, calculating protons, electrons and neutrons as a starting point. With your periodic table you would see that sodium, Na, has two numbers, 23 and 11. Protons is always the smaller number, making sure we're looking at smaller, not the bottom number, because some periodic tables flip them. So protons is always the smaller number, which is 11. And electrons, in an atom, electrons are equal to number of protons. So when we're talking about atoms, we can say that the electrons would also be equal to that small number. Neutrons is the big number, take away the small number. So in this case, 23 minus 11 would give us 12. So just going through that again, in an atom, protons and electrons are equal, and they're both equal to the small number displayed on the periodic table. Neutrons is the big number on the periodic table minus the little number, which in this case would be 12. Have another go for chlorine. So protons is going to be the small number, and because we're talking about an atom, the electrons is equal to the protons, so 17, and the neutrons would be 35.5 minus 17, which would give us 18.5. Now that I've explained how you can calculate the number of protons, electrons and neutrons using the numbers on the periodic table, I'd like you to do the same for magnesium, oxygen, beryllium, potassium and sulfur. Pause the video now and then we'll go through the answers. So you should now have had time to calculate the number of protons, electrons and neutrons for magnesium, oxygen, beryllium, sulfur and potassium. If you get yourself a different colour pen, if you've got one, we're going to go through the answers. So, on the periodic table, magnesium is 24 and 12, they're the numbers. So like I said earlier, protons is always the smaller number, so it'll be 12. I also said protons and electrons are always equal when they are an atom, so that will also be 12. Neutrons, I explained, was big, take away little, so you do 24 minus 12 equals 12. You might want to pause the video again just so you can mark the answers that I've now added to this whiteboard. So now that you've had a go at trying them and you've marked your answers for calculating protons, electrons and neutrons, we should be pretty confident with that. So we're going to move on to drawing atoms. So this is a new rule that I've just put in the middle of the board. It's showing that in the first shell of electrons, which will come apparent in a minute, there's only a maximum of 2 electrons, and then the next shell there's a maximum of 8, and in the third shell there's also a maximum of 8. We'll need to use that rule in a moment when we're drawing them. First of all, sodium, number of electrons is 11 because it's a small number. So in that first shell, I can put 2 of those electrons because it's maximum 2, and then it moves to the next shell. So we've got 2 in the first shell, we've got 11 altogether, so we can still fill the next shell right up to the full and put 8 in there. We've got 10 at the minute, 11 altogether, therefore this outer shell can only have 1. That's the drawn atom. So we can just check we're right here because we've got 2 in the first shell, so we've not got any more than there should be. We've also got 8 in the next shell, which is not over filling that shell above the maximum number of 8. And the outer shell is definitely not full, it's only on 1. Add these numbers up to 4, 6, 8, 10, 11, which matches with our electron number from earlier. Let's have a go with Cl. Similar idea. Can fit 2 in the first shell because that's the maximum number for the first shell. I can also fill the next shell because that would only get us up to 10 and there's 17, so the next shell is going to have 8 in it, And the final shell, if we got 10 now, we can only fill the final shell with 7. Because that would get us to our electron number. So you have to keep adding electrons using the rule of 2, 8, 8. So don't fill the shells more than those numbers until you've reached your electron number. So just to check, 2 in the first shell matches the rule, 8 in the next shell matches the rule, and we've only got 7, so we've not even maxed out the number of electrons in that outer shell. Just checking it matches with the fact chlorine's got 17 electrons. 2, 4, 6, 8, 10, 12, 14, 16, 17. Now that you've looked at my description of how we draw atoms out, I'd like you for each of these elements to draw their atoms out. We've obviously already worked out the protons, electrons and neutrons, and that'll help you to draw them. Pause the video and then we'll go through the answers. You should now have had some time to draw the atoms. If you get yourself another colour pen, you can mark what you've done. So, magnesium has got 12 electrons, and we need to remember the rule of 2, 8, 8, which means there's 2 electrons in the first shell, then 8 in the next, and then the maximum of 8 in the third shell. So if we start off with our first shell for magnesium, it's going to have a maximum of 2, because we've got 12 altogether. You can then fill the next shell up, because that would only get us to 10, so that would be a full shell of 8 as well. And then finally, we've now got 10 electrons in this atom drawn so far. Magnesium has got 12, so we draw one more shell with 2 in. I've now added the rest of them. Oxygen's got 2 in the first shell, then 6. Beryllium's got 2 and then 2. Sulphur has got 2, 8, 6. And potassium, the biggest, is 2, 8, 8, 1. You might need to pause the video just to mark your answers. If you're not sure where any of the answers have come from, you might want to rewind back to the original description of how we draw these atoms out and then have another go yourself. You should now have had a bit of practice, so you should have been able to have a go at drawing the atoms for the other 5 elements. I'd now like to look at them going into ions. So a really important rule, other than this one, another really important rule in this video is that all atoms want to have full outer shells, so they want to be hitting either of these depending on how big they are. And that's when they become something called an ion. So atoms always want a full outer shell so that they can become an ion. We'll start with sodium. If that wants to become a full outer shell, it's easier for this one to be lost and given away than it would be for it to try and find 7 more electrons to join that outer shell. So if we were to draw that out, 2 in the first shell like before, 8 in the next shell like before, and that outer shell with the 1 would be missing because we've got rid of it. So now that's a full outer shell. Sodium's happy because it's a full outer shell and it's become an ion. It becomes a positive 1 charge because it's lost an electron. Now the reason behind this is because 11 electrons and protons were equal, so there was no charge because the positive and the negative, because protons are positive, electrons are negative, they were equal. But now we've only got 10 electrons, so there's more positive than negative. That's why we get +1. If it was to have lost 2 or 3 electrons, it would have been +2 or +3. Coming over to chlorine, it's a little bit different because we've got 7 in the outer shell, so rather than losing 7, we're going to just gain 1. It's easier to find 1 than to try and find a place for all 7 of those. If I just draw an arrow down to the ion, draw exactly the same, 2 electrons in the first, 8 in the second, and it's where we get to the final shell where it changes. So I said we're going to gain 1, so it has that full outer shell of 8, so I'm going to just put it as it was, and you're going to make that into a dot. I'm drawing that as a dot rather than a cross just to show it's come from somewhere else, it wasn't originally there. Square brackets are really important when we're drawing ions. And this time, it's not going to be plus because it's gained 1. So we're now going to have 18 electrons. So the atom positive and negative were equal. Now there's more negative than there is positive, therefore it's going to be -1. If we gain 2, it would be -2. Gain 3, it would be -3. Now that you've heard my explanation on how we make these atoms into ions, because all atoms want a full outer shell and the ones that are on the board haven't, I'd like to have a go, pause the video and have a go at drawing magnesium, oxygen, beryllium, sulfur and potassium ions. Pause the video. Okay, now you've had time to draw out the ions of these, we'll go through it. So get your other colour pen if you've got one, and we'll have a go at magnesium together. So magnesium's got 2 in its outer shell, it wants a full outer shell, so it's easier to lose those 2 electrons than it would be to gain up to 8 in that outer shell. So you draw an arrow to show it's going to an ion. I'm going to leave those 2 out because it's going to lose those 2 electrons. Going to have the 8 in the next because they're full. That's now the full outer shell. Draw the square brackets with a +2 because it's lost 2 electrons, and that's the ion for magnesium. If you're not sure why it's a +2 ion, please rewind the video back to the explanation and it'll explain there. So here's your answers. Oxygen gains 2 to become -2 with that square brackets. Beryllium loses 2 electrons to become a 2+ ion. Sulfur gains 2 to become a 2- ion, and potassium loses 1 so it becomes +1.